This Proxmox guide, hopefully the first of many, is brought to you by Linode. So big thanks to Linode. There's a coupon below for $20. We've been using Linode forever. There's tons of old Linode ads. I'm trying to get this thing going again. I've got some other content planned for you, some Bluetooth stuff, but big thanks to Linode for sponsoring this video. Like I say, we've been using them for years, since even before the Level 1 YouTube channels. Currently running the Level 1 website. You can get $20, and there's all kinds of fun DIY stuff you can do with Linode. It's hosting in the cloud. You can host your own VPN or your own file sharing thing, file storage thing. You can have encrypted backups if you want. Although if you're just strictly using file backups, there's probably some other options for that. But running your own private VPN server, that's actually pretty legit. That's pretty cool. So big thanks to Linode, and there's a link below. Just check that out. And for now, on with the guide. Okay, so I did a video on consolidating, like how much9consolidation I was doing with a new 128 core, 256 thread Epyc server from Gigabyte. And I mean, that's no moon, that's a space station. I mean, that's sort of where we are with 128 cores and 256 threads in the day. I mean, when you're talking about consolidating, you know, older Xeon machines and replacing everything up to, and you know, you could make the argument to replace even some 3647 CPUs, because, and the SQL people in the audience will totally back me up on this, like much past Broadwell, like Xeon V4, that per core performance basically just flatlines. I mean, if you're doing like SQL transactions per second or anything like that, it's Broadwell V4 all the way up to like Xeon Gold on, you know, Socket 3647. It's basically the same story. So enter AMD with Epyc. I mean, that's the 30-second backstory. And 128 cores, 256 threads is like, yeah, they crammed more cores in here, but Intel crammed a bunch more cores on that older socket. And when Intel did that, when you had really high-speed network interfaces and really high-speed disk interfaces, you couldn't keep the cores fed. But this is not what I'm seeing from real-world production use on Epyc Rome. Even 128 cores in a box. If you want really, really high density, especially with virtual machine type workloads, this is what you'll be running, because any single application, it will struggle to use 128 cores. I mean, even across both sockets, depending on if you're going to run that as a 2 NUMA node or a setup where you've got 4 local NUMA nodes and 4 remote NUMA nodes for the near far thing, which works a little better in terms of latency, but for most workloads you don't need to bother with setting any of that. This is a complete game changer for density inside the data center, and it is not unreasonable to consolidate dozens of machines into a single rack mount machine. So the point of this video is some hints for configuring Proxmox that I've sort of gathered over the years. Now, Proxmox, if you're not familiar with it, is a virtualization platform distribution of Linux. It is commercial. You should, you know, subscribe to them. They put a lot of work into making it really easy, but it goes even beyond being just a distribution of Linux in that you can run clustered services with it. So you can set up a cluster of, say, 3 of these servers, which is what I've done, for the failover and redundancy. You know, a lot of the people in the last video kind of missed the point. It's like, isn't it, you know, if the server goes down, aren't you going to lose everything? It's like, well, yeah, if you only have one, but we're not putting 3 racks of machines into one machine. We're putting 3 racks of machines into 3 machines. And that cluster with high availability has better high availability than a hodgepodge of machines that were, you know, added over a period of like 10 years. It's a much better situation. I mean, all of your risk management people will tell you that, you know, running on borrowed time on hardware that old, and you know, every day something is going to fail. There's physically less stuff to fail on 3 physical servers because it's a software construct that's managing the availability now, or the high availability, or whatever. And with the old stuff, you know, some of those were standalone machines. There wasn't. It's like, what's the high availability is we're going to go to Veeam and like restore the backup, and that's not. It's not great. Proxmox is something that you can play with on literally anything. You don't have to have a 128 core, you know, Epyc super server to do this. There's tons of great resources online. There are tons of other YouTubers that have done like videos on how to set up Proxmox and like the super basic stuff. It is very basic. Like if you can't get through the Proxmox installation and you've got reasonably standard hardware, something is wrong. They've made it that easy. Now, on the commercial side, for the setup, yes, I was using VMware and VMware ESXi. VMware makes a lot of great products. ESXi is a great virtualization platform, clustering, commercial support, the whole 9 yards. But Proxmox, it doesn't quite have as many bells and whistles, but it is an extremely competent virtualization platform. So like if you're a school or a nonprofit organization or church or something like that, although you can get nonprofit pricing from VMware, but if you are budget constrained, then Proxmox is worth a look for the Linux platform. I mean, Microsoft, because of VMware is so good and the Linux stuff is so free, that's where we are with Hyper-V on the Microsoft side. You can get Hyper-V for free as well. You can get Windows Server for free if it's just the version of Windows Server that does nothing but be hypervisor, because that's sort of the competition landscape that we're in. And then you can do the PowerShell thing and manage it remotely and all this kind of stuff. But Proxmox, and some hard-won lessons from working on Proxmox over the years. So I've got a guide on the Level 1 forum that is the stuff that I usually do to a new Proxmox box. The first step for getting the most out of your Epyc CPU is configuring your BIOS, or at least look around and make sure that everything is good. You can configure things for performance, but it's also useful for troubleshooting. So you can configure things like you've got onboard video, maybe you're using an add-in video card. I'm using the Tesla V100s. Sometimes the BIOS, different versions of the BIOS, for example, will detect that as a card that you can actually do video out on, and it's like, not so much. So before you install that, you can come in here and be like, hey, I want to pick, there's nothing in here because there's no GPU installed in the chassis at the moment, but you can pick those kinds of things. So AMI graphic output policy is like output select unknown device. That's probably a BIOS bug. But if you've got more than one thing installed in here, so we get the ASpeed driver, that's the onboard thing. So just be aware of these options. Your SATA devices that are installed. We can see that we've got all kinds of stuff in here for the networks and this kind of thing, the network stack configuration. There's another way to get to the AMD memory configuration status in here too, which is perhaps useful for troubleshooting, that would show you things like whether or not the DRAM ECC is enabled and some other things like that. But AMD CBS CPU common options, generally all of this stuff on auto is basically fine. On the Gigabyte chassis, you don't have to worry about any of this. Some of this, like the power supply idle control, that is a real concern if you're retrofitting something older. The machine will lock or hang if you have a power supply that can't tolerate the ultra low power states of Epyc, meaning that the power supply will not supply clean power and then the system hangs, and it's just not a good situation. You can also do like custom P states, but generally if you're running Epyc, don't do this. This is crazy. It just doesn't make sense. You can disable SMT multi-threading. So when you do that, you have to power cycle the machine. The CPUs have to be turned completely off, because turning the threading on or off is not really a thing that you can do soft. That's a hard thing. So the AMD CBS Northbridge common options, most of the stuff that you would actually want to change are under here. IOMMU and ACS. Access control and IOMMU go hand in hand. So access control generally being on is going to improve your IOMMU groups. And also on a lot of motherboards, there's a difference between IOMMU auto, which is a partial enablement, and IOMMU enabled, which is a full enablement. And the reason for that is some bugs in Windows, and let's just leave it at that. There's also PCIe ARI support. It's the alternative routing implementation, and this, if you've got a PCIe device that has a lot of downstream devices that would normally be used, like the downstream devices would normally use the bits on the PCIe packets for specifying, hey, this is a downstream device, this is a downstream device, it doesn't necessarily work correctly. And so auto used to mean enabled, but I think it's since been changed to disabled. So if you're having trouble out of especially an older PCIe device, set this to disabled. 10-bit tag support is a new thing for devices that have a whole bunch of downstream devices. I think it's just moving from 8-bit tags to 10-bit tags, so that a device can have more tags on the bus, which is fine as long as you don't have any devices that will be problematic with that setting. The SMU common options, this is the option here, so we can do CTDP 240 watts. Now I had one device that required 480 watts. It was a 2-socket system, and so setting 240 watts actually hurt my performance. So, you know, run some benchmarks and do this kind of thing, because it seemed to be running each CPU at 110 or 120 watts. So I set it to 480. I was like, that's weird. So I set it to 480, and then each CPU was running at 240. So I don't. Okay, I mean, I guess. I think that has since been fixed. But, you know, just so you know, there is options in here for fan control. You can also control that from the IPMI, so you don't have to fiddle with the BIOS on that. There's also the determinism control. So the determinism slider, we can say we want performance, and the system will tend to giving us performance. It's just the same as it is on desktop, except all of the cores can do 3.35 gigahertz. So it doesn't have to shuffle your load around, or doesn't necessarily have to have a particular loading order. That might be coming in future generations, but for now, I mean, that's a thing on Threadripper, but it's not really a thing on Epyc. Boost, Fmax enable, yeah, just like the desktop counterparts. Although I've fiddled with this a little bit in overclocking, and you really do have to abuse the SMU to unlock full Epyc overclocking. I think AMD has locked that down. But the danger is not really to the processor, it's really the motherboard, because overclocking Threadripper, like a 3970X, if you're going to run 4.4 gigahertz on all 32 cores, that thing's going to suck down like 700 watts of electricity. It's really a bathtub curve to get, you know, those really, really high clocks. But you can score like 20K in Cinebench R20, so I mean, 700 watts, it's a little bit of a space heater there. In general, you won't really need to change much of anything else in the BIOS. I will mention the chipset tab, PCIe link training type, and PCIe compliance mode. I mean, PCIe compliance mode, like that just... If you're running some of those older PCIe adapters that are not exactly stable to begin with, you've got specialty equipment or lab equipment that is running off of a PCI Express interface with an FPGA, like compliance mode being off. I mean, that just, I don't know, maybe we can, like, for political reasons, we could label that something else. But know that those options are there. I personally have never had a situation where changing these has resolved an issue. It's always been one of the other issues, and you can get yourself into a situation where changing these might actually prevent the system from posting correctly. Like, I've run into situations where the A-Speed IPMI device was not able to interface, the video device is not able to interface correctly anymore after making some changes here. So just be aware of that, and be aware of these changes that you can do to the UEFI to get the most out of your system. I'm going to configure the boot order for Proxmox, save and exit. With Proxmox installed, when it boots up, it'll give you a login, and you can log in here. And it's good to know how to log in here, because in case something goes wrong, you will need to do that. But it gives you an IP address, https:// whatever IP address it got from your DHCP server, :8006. You can use that to load the Proxmox web browser and finish configuring the system. I wanted to use the ZFS GUI. The ZFS GUI works great. If you're going to use the ZFS GUI, you're going to have to clean your disks so that they're blank, because otherwise, for safety, it's going to say, nope, we're just going to do it from the command line. Not a big deal. There we go. RAID Z1, our tank is online, and now if we go to the ZFS option, hey, look, it sees the tank. Everything is online. It's going to report our status. It will email us in case one of the drives dies or whatever. You've got some really awesome stuff there. So there's Z-Pool mounted. We can click on Data Center and go to Storage and create a directory. Now, because I installed to just a SATA SSD, normally I would want to use an NVMe, but for the purposes of this video, I'm using a SATA SSD, which is fine, but, you know, again, local storage would be good. It creates a directory called local, which is stored on that local SSD. Not good enough. I've created a ZFS pool called tank. I've told it that, hey, this directory is available. It's ZFS. It knows this is under the storage tab. You actually have to click on Data Center under Proxmox. So then I'm going to create another folder under tank and just copy the varlib VZ, which is by default that local folder. I'm just going to call it local ISO. Really only going to use it for ISOs, but the content, you know, there could be multiple things in here, disk image, dumps, whatever. You know, we could store 5 backups in here. Not really a big deal. So now I've got local ISO. Looks pretty similar, except it's in my ZFS tank and it's enabled. So now when I create a virtual machine, we can see it in the storage here under Data Center. So now when I right click on this node and go create virtual machine, we call this VM101 or whatever, I can go to my OS tab. I can actually, instead of local, I can pick local ISO, And my Debian ISO should be in there unless I screwed up somehow. I did screw up slightly. It goes in the ISO folder. Which is why I copied that. You can tell I've done this a time or two, right? Come on. There we go. Good to go. Yeah, kernel, that's not gonna be, that's fine. Whatever. Yep, this is all fine. Hard drive, this is fine. We're gonna store it in tank, and disk size 32 gigabytes is fine. Cache, no cache. Unsafe write back. We'll do 4 cores and do 4 gigs of RAM. So now we've got both a container and a virtual machine. It's gonna connect and boot and do stuff. Proxmox really is a pretty slick operating system. It's worth money. It's worth paying for support. I mean, that's what you're paying for, right? But just to experiment with it, you know, you don't need the subscription. It's totally okay. And you see how just mind-bendingly fast this was. And I think I accidentally chose Algerian as our install language, but that's completely fine. That's a totally recoverable situation. And this is installing, you know, imagine how fast this would be with like actual SATA. This is pretty much just doing everything from RAM. Oh, IPv6 is not enabled, so there's that. Now, if you had a cluster of these, notice that you've got options in Proxmox like replication and Ceph. So I got a couple of questions on the last video that was like, oh my gosh, you put an entire rack in one server. What about redundancy and reliability? Well, I've got news for you. We're talking about 15 to 20 servers per rack, because the rack was not super overloaded. They were not super high density. We're not talking blade centers or anything like that. But because of the replication, the actual storage of these virtual machines will run from system to system. So that means that if I've got 3 of these brand new AMD Epyc servers running, there's copies of my machines distributed on 2 out of the 3 VM hosts. So any one of them could blow up, and I've got an up-to-the-minute replica of whatever I was doing on the other machine. Now, if it's a control shutdown, like say we've had a catastrophic power supply failure and like fire has shot out and we need to change the chassis, but the machine is still running, which is the most common type of failure mode, not the power supply catching on fire, but like something has happened and you're gonna have to shut down the machine. Proxmox will let you migrate those running virtual machines from system to system. That does take a little configuration. You have to set that up, and the whole shared storage thing, you need a fast interconnect, and the whole split node, shoot the other node in the head. There's some details there, but you can totally do that. For the kinds of relatively pedestrian workloads that we're running here, where you know you could run a clustered Microsoft SQL server where you've got VMs on each node and then the clustering is happening literally inside the virtual machine, but all those individual machines will show up here under the data center tab in Proxmox. So you know, if there's enough interest in this video and enough people have not seen that before and would like to see that kind of a setup, I can show you, but it's pretty cut and dry. I mean, if you're comfortable moving around to this extent with your system, you know, we're just setting a password that's not secure at all. If you're comfortable moving around the system like this, I mean, I'm just showing you there's not really a lot of insanity here, then you're pretty much good to go in terms of setting up the clustering. There are, well, no, I probably should do a how-to on that actually with Ceph, and by the time you get into like storage replication and that kind of thing, but it really is pretty much point and click. Now for this, because I'm setting up new virtual machines, we're actually running through the Debian installer, but if you've used like disk to VHD or the VMware tools for creating a virtual machine from a physical machine, there's a ton of different tools out there for doing that. Then you could just boot up the virtual machine pretty much immediately. All you'll really have to do is configure the network. You can maybe move from a virtualized network adapter to a para-virtualized network adapter. It really is worth installing the virt.io drivers for both IO and the para-virtualized NIC, because those have less overhead. I mean, just imagine the overhead of emulating a full network card versus just enough of the network card to get it to work, to pass it through to the host operating system. Way less overhead. It's the same deal with the containerization. We've got the PVE containers here. We can also set this up for Docker. It's not a problem. The overhead from that type of virtualization is much less. I mean, this Epyc server could run thousands and thousands of containers, whereas it might only be able to run merely hundreds of virtual machines. I mean, depending on how beefy those virtual machines need to be. But 128 cores, like, this is probably the easiest way that I can explain it. I mean, it is nuts that we've had a generational leap that will reasonably let you consolidate machines that are, 5 to 10 years old, entire racks at a time. That's what we're talking about here in the data center. That level of compression, for lack of a better way to describe it. And it really is game changing, because all that legacy hardware, all those older physical machines, all that electricity that's being used, gone. And when you implement a clustered solution like this, your reliability is actually better than the reliability of all that old hardware. I'm Wendell, this is Level 1. This has been a quick peek at Proxmox, and also optimizing your servers, like the Gigabyte Epyc server chassis that we've been taking a look at. So if you found this useful, give it an update, and if not, there's another thing there, I don't know, but give me some feedback on the Level 1 forums as to the kinds of things that I can produce that would be useful. And be sure to check out the how-to guide that goes with this video, because it's a little bit more step-by-step and a little bit less me rambling. I'm Wendell, this is Level 1, I'm signing out, and I'll see you later. So there you go, that's getting the most out of your AMD Epyc server. Now, our AMD Epyc servers happen to be Gigabyte chassis, and the configurability here is pretty much off the scale. These are an incredible value for what they are, and if you're worried about reliability and it's like, oh, we need a 4-hour support thing, we can't, I need service. Well, there's probably a local company that will actually sell you Gigabyte chassis and provide the level of support that you need. But when we're talking about a 3-server cluster, it's not a 4-hour response time, it's a 30-second response time, because if one of the machines in the cluster goes down, immediately the other 2 start spinning up virtual machines, and they take over the load immediately. Gigabyte doesn't play any games with the IPMI licensing. It's fully unlocked. It supports everything virtual media. It's the $300 IPMI option. The cost is better than other major OEMs, at least here in the US, and I feel like I have to plug them a little bit because nobody knows about them, but in the data center and in other markets, they're actually sort of a force to be reckoned with. But here in America, it's like, Gigabyte rack server? But then you look at it and it's like, okay, I want to use all my NVMe, all my PCIe lanes for NVMe. Okay, the whole 128 lanes are going to the front. It's like, oh, you don't want to do that? Well, you can do 64 PCIe lanes with the PCIe muxes, and then take 64 lanes for other stuff, or 100 gig network interface, or mixed 100 gig network interfaces plus storage into single or dual socket. We've covered pretty much everything. Check out our other videos on these chassis if you're curious. They're all available in Roam configurations. This machine has the 12 3.5-inch drive configuration, so a little bit bulk storage. Don't know that I would pair that with 128 core CPUs, but you can, and you can mix and match, and you can do whatever, because it's all modular. It's got the OCP 2 and 3 slots, so again, it's all modular. You can mix whatever network interfaces you want. All the PCIe 4 storage internally that you could ever need. It's pretty awesome. I love not being nickel and dime to death. There's nothing more frustrating than getting a really high-end server, and then you're gonna DIY some upgrades to save some money, and then you pull the power supplies out, and it's like 500 watt power supplies. What is this? No, these chassis are all, everything is top end. It's good stuff. I mean, these are all 1,000 watt plus, modular power supplies. It's good job, Gigabyte. I've rambled enough. I'm Wendell, this is Level 1. This has been getting the most out of your Proxmox configuration while I'm troubleshooting that ZFS thing, but I think the ZFS thing's been fixed. So run the patch on your kernel and let me know, because I've run it for a few days now and it's been fine. I'm signing out, and I'll see you later.